Welcome back. In this video, we'll explore how to expand our capabilities by understanding and utilizing its vast ecosystem of functions and packages. This is where R truly shines, allowing you to perform almost any data task imaginable. This video demystifies the concept of functions and packages in R, which are essential for extending our core capabilities. So we will start by explaining what functions are, which are basically reusable block of codes that perform specific tasks and demonstrate using common built-in functions like mean, sum, max, min, and SD, which is standard deviation, with a vector of stock returns. We also show how function arguments can modify behavior, um, like na.rm, so not available, where you assign it true. We briefly touch on how you can create your own simple function for repetitive task, which I used a lot in my book. The video then moves to packages, which are collection of functions, data, and compile codes that enhance R. We explain that packages are installed once using install.packages function, which we will demonstrate using the quad mode package. And then loading into each arrow session using the library function to make the functions available. We give a quick example of using get symbols, um, which I've done in my previous video, but we'll go through it from the quad mode to download stock data, showcasing the immediate power of leveraging packages. We also briefly show ggplot example to demonstrate package-driven visualization. Okay. Okay, like I mentioned, functions are reusable block of codes. Functions are named block of code designed to do a specific task. They take inputs, which are arguments, and then they produce outputs. So here we're going to show built-in functions, which we've seen some already. So example here is to calculate descriptive statistics of a numerical vector. So we assign this vector um, of stock returns to this variable stock return, run this, and then we're gonna check the mean of the stock return, sum of this calculates the sum, length function gives you the number of items, max gives you the maximum value, likewise mean gives you the minimum value, and then SD is the standard deviation, which measures the volatility of the stock returns. Functions arguments. So many functions have optional arguments to control their behavior. So we have example here, mean function with the uh, not available or missing value removed. So here we have our vector with the numbers, including a non-available item here. So we run it, right? Assign it to this variable. And then what we're gonna do, we're gonna run a mean without the NA, right? So this result, this will result in NA because of the, if you run with NA, sorry, it will result with the NA, right? So here, because it's true, this, but if you assign the parameter true, this removes the NA before the calculation. So we run it, we get our mean or average calculation without the NA. So yeah, we are gonna create our own simple function. Um, you know, briefly for this task, you repeat often. So instead of doing this calculation often and on, you can wrap it in a function and then call up the arguments and then do calculation for a variety of tasks. So here we are going to create a function called calculate dividend yield, where the arguments we have annual dividend. You can give a parameter for annual dividend and then for current price. and then it will calculate the yield being the annual yield over current price times 100, and then it will return this yield rounded to two decimal places. So we've created the function here. Now we're going to use it to calculate the yield for Apple here, where we're going to assign the annual dividends for this fraction and then their current stock price. So if we run this, run this, then you paste the value with this string. So this is sort of the if you use the paste function to paste sort of a descriptive title to your actual calculation, and sort of, I will not call it concatenate it, but combine it with other characters. So I print this, and it tells you this is the yield in percentage, right? We can do the same with Microsoft yield. So here you can see we are not calling the argument again because it's positional. If you put 2.8 here, it will recognize that that is for the annual dividend. Likewise, the stock price is the second position, right? So this, you are using the position matching tool without calling the arguments, right? So you run this, and then that's the yield for Microsoft. Okay, part two. So for the part two will be the packages, which is collection of functions and data. So packages extend arrow based functionality. They are like apps you install in your phone. So here, because I've already done it, that's why I comment it out. But if you haven't, you can install a package. It's a one-time process per arrow installation. But the library, you have to load the library each time you start a new section. Obviously, this is your way of installing your package name in quotes, using this function. Here we install quad mode, quant mode, which we've done already. If you haven't, you install it. This is how you install it, to run this line once and you don't have to run it again. So because I've installed it, I don't need to do it again. And there's other videos why I ran this quick process. Okay, after you install it, now we're going to load the library for quant mode. Run it. Now we have it loaded, and we want to access the get symbol function in order to load our stock price. So here we're going to download the Apple stock price, and then we're going to create an object using their ticker, right? So here get symbol will, our source is Yahoo Finance, and then we're gonna auto assign as true to this object. So run this, you check the head. So the head again, 1, 2, 3. So yeah, like I mentioned before, it will give you the first 6 rows of your data. So that's your Apple stock price from open, high, low, closing price, the volume traded, and then the adjusted value all the way from. So by default, it starts from 2007, but you can also, use the argument from and assign parameter from the date you want to start it. Okay, I give an example of Canadian aristocrat dividend stocks, which that's what my book is all about. I'm gonna load the Enbridge stock here. The same, assign it to the ticker, and then we load it to view the few um, stock data. And as you can see, this Enbridge stock data from 2007, right? We can check the tail, which shows you the last few rows of your downloaded data using the tail function. So I run this, you can see up to yesterday, not yesterday, I believe this should be Friday. It gives you the last 6 rows of your data. So here we're gonna do the plotting package using ggplot, which is part of the tidyverse package. If you haven't, this is how you install the package. Already I have. So here I will just load the library. I'll create a simple scatter plot using the ggplot, just to show you the visual. So we assign it to this variable, create a data frame here with x and y variables or features. and then you call your gg function to plot basically your y to your x, right? So this is your data, and then this is your x and y. It's gonna be geometrical points, so it will show plots, the line in points, and then this is the title of our. This is how you assign the title of your labs. If you want to assign title to x and y, you can also do it as well. Using the functions for assigning the names for your x and y. But here we're just gonna run a simple plot here. So we run it, you can see this is a very simple scatter plot here that we ran, right? So yeah, um, very simple plot here. So yeah, functions and packages are what makes R incredibly versatile and powerful. You now understand how to tap into the vast ecosystem. I use this extensively in my book to, do portfolio analysis of stocks for the dividends aristocrat stocks. Workflow using a lot of packages was used in order to do the financial analysis and then obviously do some data analysis. So next we're gonna you know go into loop in R where you basically be automating repetitive tasks. Okay, thank you for watching the video and see you in the next one.